It is a real delight to be able to introduce today's colloquium speaker, Bjørn Jespersen from the University of Utrecht in the Netherlands. And Bjørn is a philosopher who works at the intersection of logic, philosophy of language, and metaphysics. He is the author of many articles, including a sustained body of work on procedural semantics for natural language, on which he's also co-authored a book. And among other things, Bjørn uses this formal framework to address traditional questions about the unity and the structure of propositions, and questions about modality and many other things. And today, Bjørn will be talking to us on the topic, as you see, of impossibility without impossibilia. So Bjørn, the screen is yours.
Thank you. So I was told we would be a mixed crowd today, some philosophers, some logicians, some mathematicians, some linguists. So I decided to sort of go light on the metaphysics and be heavy on the formalisms today, because that's what we all share. Right. So here we go. So my current project is impossibility and how to account for that. And I want to draw a distinction between reasoning about impossibility and reasoning from impossibility. And today I'll be talking about reasoning about impossibility, which is all about how to make sense of the notion of impossibility. How many are there, as opposed to reasoning from impossibility, basically where we would have one or more premises that would be impossible, and then what would follow from that. But that's for another occasion. Today it's about reasoning about impossibilities. We're laying down the foundations. So if you consider the derivation I put up there, a divorced bachelor walks in the park. What would follow from that? What would the logic of that derivation be? Well, that depends in part on how we make sense of the premise. So what is a divorced bachelor? Right. Is that premise possibly true? Is it necessarily false? And whatever your answer is, why is that? And so today I'll be looking only at the premise, of the logical form of the premise. But this is, like I said, this is about foundation. So the logic that would be developed here based on these foundations shouldn't, of course, just be classical, because then we can infer whatever. We don't want it to be sterile either, because then we don't have a logic. So we want to be able to draw some inferences and block other inferences. Otherwise, we don't have a logic. That's the bare minimum. So as I said today, it's about predication. What are predicates that are impossible? What are objects that are impossible? And how do we predicate? How do we end up with predications that could not possibly be true? And I want to account for the notion of impossibility without in any way invoking impossibilia. Impossibilia are impossible objects. The round square is a standard example. A divorced bachelor would be another, but also impossible worlds, also impossibilia. And I want to do without those. So where does that leave me? Right. Those are the blanks I want to begin to fill in today. My position is extreme. It gives absolute conceptual priority to concepts over objects. It gives absolute conceptual priority to conditions over satisfiers, this gives absolute conceptual priority to procedures over products. So the basic idea is that we start at the top, and then we descend as far to the bottom as we can get. Whereas if you go the opposite direction, you start out with a rich ontology of objects, including impossible objects, including impossible worlds, and then you work your way up from there. And I'll talk about that more in a second, but let's make sure we start on the same page. So if you just take absolutely standard possible world semantics, then you have two limiting cases, impossibility and necessity. In between, you have contingency. And the statement I put up there on the slide is a very standard formulation of what standard possible semantics can do in terms of impossibility. So so impossibility is simply the negation of possibility, or equivalently the necessity of negation. And I put up some simple formulas there that show that. Right. So we can formulate duality for impossibility. So we have a notion of impossibility, but it's just very meager. But let me just quickly contrast impossibility with possibility. Impossibility is on the same page as necessity, because it's a limiting case. That's why we can, for instance, use conjunction introduction if in the case of box alpha, box beta, or impossible box alpha, impossible box beta, and form their conjunction. Nothing wrong there. And it is, as it were, just the empty logical space twice over. Whereas, of course, we couldn't do that with the diamond. Right? Then we get a well-known fallacy, right? Because alpha may be possible in one world, and beta may be possible in another, may be true in another world. So alpha is true over there, beta is true over there. They need not be true at the same world. This is all par for the course. This is well known. And we also know what is wrong with that. And that's why I call it meager. Because we just like we just have one necessary in a logic of totally defined functions, totally defined intentions. We only have one necessary property, only one necessary proposition. One necessary individual concept. And if you just invert that, when we just have one impossible proposition, one impossible property, one possible relation of a certain arity, and one impossible individual concept. It's indispensable, right? It shows it tells you the extensional story of impossibility. It is nowhere true. And that's it. But if you look at intentional with T attitudes, such as belief, we don't run into a tricky issue. You'll know this from epistemic logic, that any belief must be consistent due to D. Due to seriality, the alpha that you believe to be true must be true at some world, and we are restricted to a logical space of possible worlds. So alpha must be a possible truth, which rules out inconsistent beliefs. And you could go down that path. Because that view has an honorable pedigree. Hume is famous for that. We cannot simply have impossible or inconsistent beliefs. But suppose we do want to make room for that notion, as I think we should, then how? How do you do that? We cannot just do that by means of standard possible semantics, unless you want to follow some intentionalist route as they do in awareness logic, where you are not related to a truth condition, you're related to a formula that then represents a truth condition. That's intentionalism, and we don't want our agents to be held hostage to a particular notation. Secondly, if you're asked to assume alpha for a reductio, then if alpha is a necessary truth, then what? What are you being asked to do? Where would alpha be true? How would you model the assumption for a reductio that alpha is false? You couldn't. We have a problem with nomological impossibility. Even if we could perhaps make good sense of nomological necessity within standard procedural semantics, simply by saying that nomological necessity is soft necessity. So a given subset of logical space will represent a certain set of laws of nature, and they're eternally true in that set. Maybe. But then you have to buy into a certain philosophical position on nomological necessity, namely the Tretzky-Tooley view of nomological necessity as soft necessity. And I think we want our framework to be as neutral as it gets before we go on to decide in favor of a particular philosophical stance. And we got counterproposals. Perhaps the most obvious case where modal logic cannot handle all modalities. So counterproposal has a necessarily false antecedent. So of course we get vacuity because of the semantics for the implication. If you're Tim Williamson, you're fine with that. But if you're distinct from Timothy Williamson, you have a problem with that. You want to differentiate between different counterproposals. So here's something for the fans of Jimi Hendrix. If 6 were 9, then Vulcan would be the third rock from the sun. That's a very different antecedent than a number of others you could come up with, and they shouldn't all just come out vacuously true. So these are 3, perhaps 4 arguments just off the cuff in favor of going beyond possible world semantics. And you can go down a number of different routes, but one is to invoke impossible worlds, and that view, did I put that later here? Well, basically, you take your possible world semantics and then you beef up your logical space. You add impossible worlds to your logical space. So you form a union of possible and impossible worlds, and you have a complicated traffic, but a traffic between the 2 spheres of your logical space. And some theories will add impossible objects. So they will allow in their domain, which stands in preach is the constant domain, you will allow impossible objects. So you have this one super domain, and then you can pick out an individual. Some will be impossible, others will be possible, and the possibles will only exist at impossible worlds, and the possible ones will exist at some possible worlds and at some impossible worlds. So there's if you consider me a possible individual, I hope you do, then there are impossible worlds at which I exist. I exemplify properties at an impossible world. So you front load impossibility. That's what I mean by working bottom up. You front load impossibilities, impossibilia. And then you base your semantics around that. That evoking impossibilia is technically speaking continuous with possible semantics, and that's often an argument in favor of doing that. You could be, as it were, reactionary while also being bold by adding those bold entities to your ontology. That's a circumstantialist theory. I got this term from Dave Ripley. So a circumstantialist theory thinks of meaning in terms of truth supporting circumstances. And in order to make to make a necessary falsehood come out true somewhere for its truth conditions, you need an impossible world where that necessary falsehood is true. Right. So that's circumstantialism. And modal Meinongianism, or nonism, that's Francesco Berto and a current priest put together, is entirely immersed in the world idiom, which is perfect for me because that gives me something to play off against. I'm a structuralist. I think of meaning as structured. It can be minimally structured. It could be structured in any number of very expansive ways, in very elaborate ways. But it's always, meaning is always structured, even if it's just a one step. And procedures are examples of structures. Some structures are procedures. We're still informal at this point. I'll give you we'll get to all the definitions, but procedures are, logical procedures are prescriptions that tell you which operations to apply to which operands to obtain which other object. Structuralist theories come in two flavors, Freudian, Russellian. These are just loosely used monikers. If you're Freudian about it, it means that you allow as parts of your structures concrete objects like Mont Blanc and abstract things like properties. That's Russellian. And if you're Freudian, you always want abstract objects as constituents, right? So you would have a modal presentation of Mont Blanc as a constituent in a Freudian structure, whereas Russell would have the rock itself as part of a proposition. I'm Freudian, right? So I don't have Mont Blanc in my procedures. That's nothing, because every part of a procedure should itself be a procedure. There's nothing procedural about a rock, but there's something procedural about the instruction to grab that rock. Again, we'll get formal in a second, but that's intuition. So I have a one-step procedure that basically says, reach into the type of individuals and extract from that type a particular object, namely the object that is Mont Blanc. Okay, now the ball is rolling. We can do something with Mont Blanc, the mountain, such as predicating properties of it. So the modal Meinongians have appropriated the term Meinongianism from Meinong. So I thought I'd just appropriate Freudianism from Frege. So I'm calling this theory procedural Freudianism, slightly tongue-in-cheek, because it's just transparent intentional logic. It's just using a different name. But but you have the contrast though between modal Meinongianism, Meinong, plus including possible worlds, versus procedural Freudianism. So it's all about procedures, working top down. That's the contrast I want you to focus on. And I'll develop my theory within the confines of possible semantics. Sorry, within the transparent intentional logic. And we have in our ranks everything, it seems to me, that we need for that sort of theory in its present stage, at least. We just need to unfold it. I'm sure we'll need to have to add something at some point, but we have everything in place already. So it's just about making it explicit. So this is the book, the 550-page monster we put out 11 years ago. And since then, we've been working on a number of objects. Impossibility is one of them. Fictional discourse is another topic that some of my colleagues are working on. Quantifying N, which I'll mention at the end, is also something we've been looking into quite a bit, because then you can really test your framework. Property modification is another one. Yeah, let me leave it at that. So, in case you're not familiar with transparent intensional logic, and most are not. I know Lionel is, though. You've been to Logica too often for that. Not to miss that. But so till, formally speaking, is a hyperintensional partial, I mean, we have partial functions, typed lambda calculus with a ramified type hierarchy. That's what it is, formally speaking. So we think of fine-grained meaning. So fine-grained here is a semi-technical term that means more finely individuated than up to logical equivalence. So that's just hyperintentionality. So fine-grained meanings are procedurally structured flow charts. A flow chart in the sense that the functional value of a given application will then become an argument for a subsequent application. So these flowcharts detail which logical operations to apply to which operands or which types. And we'll be talking about type theory today, because it's quite critical that we are within a strictly typed universe. Because, for instance, that helps us evaluate different sources of impossibilities. And it tells us what the type is of the object that we would have obtained if per impossibilia we had such an object. So the largest prime has a type. There's no object with that type, but we still have the type of the largest prime. I'll show you how that works. Which types to obtain a product of which type? Okay, so we draw inspiration from Frege and Church and Montague, and not from the other camp. So that would be Kaplan and Kripke and so on. We're not in that camp. And also procedural or computational or operational semantics, as some would know from programming languages, or functions as rules, which is of course just pure Church. So, and our ideography or symbolism is an interpreted lambda calculus. So interpreted because we assume that our lambda terms already have meaning. We use the lambda terms to denote our procedures. So our ideography is an interpreted lambda calculus whose terms denote procedures. And this logic has three tiers. It's trickle down. I wasn't sure if it could use the term trickle down with an American audience. So, but trickle down semantics works. It's not voodoo semantics. So we have a top procedures, and again, it's a ramified top hierarchy. So we have procedures of increasing orders. But anyway, the top tier consists of procedures, fine-grained, structured logical objects. Below them, we have conditions. Typically intensions. Intentions are just what procedural semantics says they are, namely functions from logical space to whatever, and satisfiers. And you can have another any kind of object as a satisfier, but in the most rudimentary case, an individual would be a satisfier. Who is the richest man or woman in the world right now? Right. So the satisfier would be an individual. Putin, perhaps, I don't know. And some procedures, and that's important for us, yield no product. So some conditions have no satisfier. And that is just straight up anti-RAM Platonism. And I'm fine with that. So it is top down to an extreme degree. So I'm front loading all of these procedures. If you take that away from me, I have no story to tell. But that's where the action is. The action is not so much in modal space or logical space, because our modal logic is just old school S5 with a constant domain. And what do we have in our domain? We have bare individuals. There are no individual sentences in this theory. Barker Marcus said that bare individuals are pegs on which you hang properties, and that's exactly what they do for us. And formally speaking, they're medetic functions, so functions without arguments. Everybody here who's listening is a medetic function. And just to drive home the point, the kind of impossibility I'm offering here is strictly hyperintentional. Intentions barely play a role. We just have two extreme cases of intentions, that's all. Individuals play no role here whatsoever. The only drawing I thought of an insert here today. So those are, Meinongians are used to ridicule, and they get prickly, and I think they're entitled to become prickly because it's actually a very serious theory that's been worked out very neatly. So I should make clear, I have respect for the Meinongians. Both camps, both Zoltas, lighter version of Meinongianism, and then priests, which is extreme, but it's just, and he knows that his metaphysics is funny, but he's concerned about getting the logic right. I think he's just not concerned with the metaphysics. I'm slightly more concerned with the metaphysics because I want to know what an impossible object is, and I'm not sure that's his concern. So we might also be slightly speaking at cross purposes. Anyway, so if you have modal Meinongianism, then you, like I said, expand your modal, expand your domain, you expand your logical space, then you get myriad impossibilia. So that's classical Meinongianism as well. That's what Meinon would to some degree have subscribed to. There are objects that do not exist, but they're objects. Till is more like Zelda, right? Because he distinguishes between ordinary and abstract objects, and his abstract objects are pretty much, but not quite, our procedures in some cases. In other cases, they're like intentions. I'm not sure he has the sort of sharp distinction we have between hyperintentions and intentions here. But anyway, when I start talking about requisites, the requisites of intentions, that maps very neatly onto what he says about abstract objects encoding properties without exemplifying them. So he and I have sort of the same understanding of Vulcan, right? Leverrier's absent planet. Vulcan isn't just anything, it's not nothing. There are lots of predications that are true of Vulcan, but doesn't mean that there is a planet out there of which it is true, that it is such and such. But there's an abstract object that encodes a number of properties. And if instantiated, then the object that instantiates that will have those properties in physical space. And Solta does not have impossible objects in any Meinongian sense. The way we would make sense of the notion of impossible world is as a condition, not a world, but as a condition that no possible world could possibly satisfy it. And likewise, what they call an impossible individual is for us a condition that no individual could possibly satisfy. And the only publication we have so far on impossibility deals with impossible individuals, which for us are necessarily hyper offices, so hyperintentional individuated individual concepts, offices we call them, that could not possibly have an occupant. And there are many of those, right? In standard possible semantics, you just had one. It would just be the function that takes every world to a blank, where in that blank you would expect an individual. but I want to offer an outline of a general theorem of impossibility today. So for us, if you look at it more linguistically, if you have a predication like A is an impossible X, then the predicate impossible X is a case of privation, where impossible would be a modifier that had a privative effect on its argument. So just like fake banknote, right? That's not a banknote that is fake. Fake banknote is a non-banknote with certain features, such as looking like it and being passed off as a banknote. Similarly here, an impossible individual is not an individual that is impossible. It's something of a different type of object. And that's why I want to shift upwards. So an impossible object, round square again, that's not a square, that's not a figure. That's not a shape with certain properties. It's no shape at all. I think my main beef with Meinongianism is that it completely misconstrues what impossibility is about. It's not about an object that has certain funny features. It's about let's speak loosely, it's a description that has gone wrong. So they couldn't possibly have a descriptor. That's how I think of impossibility. There's something abusive about impossibility. You're abusing otherwise coherent notions. So just before getting shifting from philosophy to logic, but I want to paint some pictures in your heads. So my objective is not to find fault with impossibilia embracing theories and then come up with a superior proposal. It's not that there's anything inherently wrong with the theory. It's just that they have take a very different philosophical stance. So what I want basically to do is come up with a structuralist counterproposal, because the Meinongians are winning the day. That's the received view these days. Well, just use impossible worlds and you're fine. No, right? So I want to come up with a counterproposal that suits us Phrygians. Therefore, the task is, what does a procedural theory of impossibility look like? And we gave one answer in this publication, came out earlier this year, but that was just about hyperoffices like VF, where no object could possibly be the unique F. So how do we go about things until? Well, if you give me a piece of language, I do a type assignment. I assign types to the different abstract and concrete objects that are being referred to by different parts of the piece of language you threw at me. Every meaning of each item must be a procedure. The meaning of a sentence, or any molecular, but let's say a sentence, is a molecular structure, each part of which is a sub-procedure. And the items that each sub-procedure produces must interact logically with the other bits in such a way that we obtain a molecular whole with W, with interacting parts. That explains why we can have differently typed input and end up with a product, and in this case, a structured hyperproposition that produces a type of object that no part produces. For instance, producing a truth condition, although no part produces a truth condition. That, in essence, is the formal variant of the problem of the unity of the proposition that Meinong brought up. So everything gets typed, and we have structures with interacting parts. That's what we have. and the ideography has to keep track of how that works. Never mind. So here are 3 examples. I will be going through the first one in detail. So the definite description of the largest natural number expresses the procedure that is structured and typed to produce an entity typed as a natural number. The procedure produces nothing and so qualifies as an improper procedure. Improper is a technical term that applies to procedures. A procedure is improper if it produces nothing, but is nonetheless a procedure. So empty terms are paired off with procedures that produce nothing. And at long last, some formalisms. So I won't go through this entire definition, but these are 4 of the 6 procedures that we usually use when analyzing natural and some kinds of mathematical language. And it's, of course, it's just a thing from the lambda calculus. But there's, first of all, variables are not terms. They are procedures. They are abstract objects, and they each, a given variable produces. And whenever I say produce, you can translate that into percent if you want to be freaking about it. Produces is a technical term. Produces the value that has been assigned to it by an assignment function. So you have a symbol, could be an X, the letter X, which expresses a procedure. That procedure says, reach into the type that has been assigned to the type of the value that has been assigned and extract an arbitrary element from that domain. That's what a variable does. So, and the third corner here would be the value presented by the variable. Trivialization is, as it were, it's not the dual, but it's the counterpart of that. It's just it's not a variable; it's a constant. But again, it's not a term. A trivialization is an atomic procedure, which says grab the trivialized object. Right? Just as a non-descriptive proper name simply gives you that object. Connecticut, boom. No description. A trivialization just says reach, as I did before, reach into this particular type and extract a specific object. So we can trivialize Mont Blanc. We can also trivialize pi if you like to. Be dumb, right? Because you don't know which number to extract because you're given no description here. But you cannot trivialize what doesn't exist. So every trivialization is a proper procedure, just like variables are. Then we have a composition that is the procedure of functional application. And because we have partial functions, a given composition, procedure of functional application, can be improper. Closure, that is, has another name, lambda calculus, abstraction. That's the procedure of functional abstraction. Tells you to form a mapping. That's never improper. At the very least, the product of this procedure of functional application, functional abstraction, will be a degenerate mapping. But however degenerate, it's still mapping. And that's enough for these purposes. Then we have a simple type theory, truth values and individuals, of course, but also reals, in case we're analyzing natural language, because we want time to be discrete here. Of course, if we're doing a number hierarchy, we shouldn't start with the reals, right? But for natural language analysis, we start with the reals. as basic type. And the possibility we do allow ourselves are possible wills. They're simply given, but they're possible wills. Those are the four basic types we have, and then we can. There's a the last clause here. We can then form functional types over these basic types. Straight up, Montague, Church, what have you. Right? These are the intentions you would expect, except that we have a little. We go one better than Montague, I'd like to say, right? Because his type S is world-time pairs, and S is not a real type; it's just contextual. But until we have worlds and times separately, so you can have variables W ranging over worlds. You can have different variables T ranging over times. Sometimes you want to keep one parameter fixed and the other one floating. And sometimes you don't. And today we don't, because we talk about impossibility. So there's no temporal variation. There's no there's no modal variation. Right. So I'll just freely speak of world-time pairs, although strictly speaking, intension is a function from worlds to chronologies, where chronology is a function from times to whatever. Sets, individuals, tuples. The formula I put down there, that schema is, if you've ever read any TIL, you will have come across that one. If you see that one, that means you're in TIL land. So this is the closure that says, that tells you to form an intension. So if you calculate this closure, you will end up with something typed as an intention. We have contingent intentions. The richest person in the world. Sometimes a world and a time will have no one richest person. In other worlds, it's Putin, and other worlds, it's me. Very remote worlds, but right. That's as contingent as it gets, and then we have, the extreme case, all nothing. You couldn't tell from this schema which sort of intention you'd form. You would know the type, but you wouldn't know if, just by looking at the schema, if it was contingent or extreme, trivially false, trivially true. You wouldn't know. You'd have to compute that. And that's important when you get to attitudes on the last slide. There are two key definitions until procedures and types, and we just did the simple types. They're incorporated into the ramified type hierarchy, which keeps track of basically the increasing order of procedures. But every single procedure and some extreme mappings with domain or codomain in procedures will be higher order objects. So our intentions are first order objects of a higher degree. If you want to, we have higher order objects, but they're procedures or intentions with domain or codomain in procedures. I won't go through this here, but this basically says we can always go one up. So if you have a procedure that you want to present, you present that lower order procedure by means of a higher order procedure. How does this work if we get down to it? Well, the largest prime can be formalized in a number of ways. This is a fairly straightforward one. We have ways of privileging certain procedural, certain formalizations of procedures above others, at the expense of others, but that doesn't matter today. So this is one way of formalizing the procedure of the largest prime. And you wouldn't know just by looking at it that this procedure would be improper by not producing a product. But you could calculate, given the types that I've left implicit, but they're usually spelled out. You would know what type of object this procedure is typed and structured to produce. So when I'm talking about the largest prime, this is what I'm talking about. So if you like, this imposes a condition on the domain of natural numbers. Is there in that domain an item that satisfies this condition? This uniqueness clause. That's an interesting question. Semantically, my job is done when I've done this. Then the mathematician takes over and tries to isolate or identify that object. And then comes back to me empty-handed and says, don't do that again. You gave me a procedure that yielded no product. Right? But that's a mathematical fact. Because there is no singleton from which the inverted iota can extract that single element. Similarly, it's a natural number between 0 and 1. Again, it's a condition we can impose on a domain. Do we get a set? Right. This is typed to yield a set. What's in that set? What are the elements of that set? We have a condition below, which is not empirical, but is built up from intentions. So we build up from something empirical, because we imply intentions to empirical parameters, Wilson times. That's when we go empirical. We go to Wilson times. So we have intentions in here, but this doesn't yield anything empirical. But so that's why I said you couldn't tell just from the schema of explicit internalization and temporalization that whether you would end up with a trivial or a contingent intention. Here you end up with a trivial one. You couldn't possibly have a Rosenbarger. Right? But again, that's something for the logician to figure out. As a semanticist, or when I'm wearing my semantics cap, that's what I give you. So the first example here is this. The largest prime is a prime. By the way, what are your intuitions here? Is that trivially true, trivially false? Does anyone have an outspoken intuition here?
I'd say trivially true.
Trivially true?
Yeah.
You can have that. Yeah. Because I can offer two interpretations here. So I got trivially true. Have we got? Remember, we got improper procedures. We got partial functions here. So gaps are an option. Does anyone go for a gap? Gaps, anyone? No takers? Okay, I'll take it then. I'll give the gap version first. So if we have what we call I showed towards there, but intuitively first. This is predication d'array. We don't call it that because that we reserve that for intentions, but predication with extensional occurrence of the procedure that occurs in as a functional argument here. So everything with the inverted iota and towards the right. So the subject of predication that occurs extensionally because it tells us to obtain an object, a number, and that number is then predicated to be a prime, a member of all prime numbers. this thing with the iota, that the composition is of course improper. Right? It is structured and typed to produce a set of primes and then extract its single argument. But there's no such argument. There's no such set, so you don't have the right input argument for that singularizer function, which has as input a set and as output the unique element. So the procedure that is structured and typed to yield the largest prime is improper. It's in fact a strictly empty or strictly improper. It's strictly empty, right? So it's valuation improper because it doesn't matter which valuation you take, you always end up with an improper procedure. There are two sources of improperness. It's at the bottom here. So either you do have an input, you have an argument, but you don't have a corresponding value. So because we have partial functions. So if I were to consider the office of the King of France in the actual world at the present time, I would get a blank. I'll get a gap. So we have an input, we don't have an output. But we can also start out with a blank and end up with a blank because the function that we are trying to apply doesn't get an input to convert to an output. This is extreme improperness, but that can happen, right? You can think of the flow chart. Output gets equivalent to input, down. That stops when I prematurely do not have, we still have some steps to go, but ends abruptly, prematurely, but I don't have the right sort of input for my function, so I cannot give you an output. So if I don't have a number that is the largest prime as an input, I cannot input that, offer that as an argument to the characteristic function of the set of prime numbers. So I don't get a truth value as output. And that is exactly what happens, right? So it's neither true nor false that the largest prime is a prime, because it is not true of a number that it is a prime. So that's not good enough for Andrew Tedder. It's good enough for me because the semantics works just fine. But there's something, that's perhaps your intuition here, there's something unsatisfactory about that because there is a link between the largest prime and prime. Right. And here you go, right, that's what you wanted. I haven't filled in the details here, but this basically says that we call that we developed that as a theory of concepts, but basically the procedure of prime subsumes the procedure of the largest prime. So in this case, this is critical. So it is important that we can trivialize a procedure, right? So the closure with the composition with the inverted iota in it has itself been trivialized. That's the subscripted mode. So I'm displaying that procedure. I'm not descending to the type of its product. I'm staying at the level of the procedure. Here's the procedure. Look at it. It's a functional argument. I can predicate something of that procedure. And I'm saying of that procedure that it is subsumed under another procedure. Of course, we are one step further up, one order higher up in the ramified type hierarchy, because we're using higher level procedures to produce lower level procedures. The upshot of this predication, with a very different logical structure, is T. So we have the triviality, if that's what it is, that the largest prime is the prime. But at no point have we dabbled with a number, only with the type of a particular number. And we know exactly what that number, what any such number would have to have by way of properties, because I just told you. And we know that went nowhere. Then we turn to a slightly more involved case, because now because as you saw, when we are in mathematics, we completely cut out the middleman. There are no intentions there. When we're dealing with intentions, when we're dealing with natural language, we have all three tiers. We have the procedural hyperintensional level. We have the intentional level for contingency. And we have, because it's not raining all the time, and Peter is sometimes happy and sometimes not, and all the rest of it. Then we have extensions, truth values, right? At that world, at that time, it is true or false or neither, that's so-and-so. And then we have individuals. Biden is the American president, right? So I'm talking about this specific individual. We're saying that he's the occupant of a particular office. So we need to include the intermediate level of intentions here. Except, of course, when we're dealing with analytic impossibilities, empirical impossibilities, we're only dealing with extreme intentions. So here's our example. So think back to the initial slide. Barthold is a divorced bachelor. I'll treat divorced here as an intersective modifier. So I can just split that predication of a modified property into two atomic predications. So Barthold is divorced, he has that property, and he has another property, he's a bachelor. We wouldn't know that was impossible. We wouldn't know. We would have to do some computation here. We would have to look at what we call requisites, we'll get to those, which are basically intentions that go into defining other intentions. So if you want to occupy the intention to be an instance of the intention, the American president, there are certain requirements, and those requirements are requisites. You must be a US citizen, you must be born in the United States, you must be above 35. Those are requisite properties. Being divorced comes with requisites. Being a bachelor comes with requisites. And as you spell out some of those requisites, you end up at some point with a paradox. Because if you're divorced, you were previously married, right? And if you're a bachelor, you were not previously married. So Barthold is and is not at the same time previously and not previously married. Can be. So Barthold has an impossible property. So the constant value of the intention, in this case a property, produced by this closure is the empty set of individuals. Go to any world, anytime, you will invariably find the empty set of individuals as the value of that property. And again, we're in a type universe, so every type comes with its own empty set. The empty set of reals is a different entity from the empty set of individuals. So let C be a procedure, then C is an empirical procedure if and only if C produces a non-constant intention. Right, because we want modal and temporal variation. But a closure of the form that we use for explicit internalization that produces a constant intention is a non-empirical procedure. So that's the Russell-Barber again. There's no divergence between any two random world-time pairs. So the intention is either a gap or an empty set, depending on the type of the extension of the intention. And also it's the fact that we truth value gaps is extra important here because that applies not only to propositions, so truth conditions, but also to relations and properties because they are characteristic functions. So they're the type of their output, their values are truth values. Okay. So what are requisites? I'll read this. The underlying idea behind requisites is that a set of requisites are individually necessary and jointly sufficient conditions for an individual to instantiate the initial property. So here's you start out with an intention, could be an office, could be a property, could be a relation, then you stack other intentions on top of it. And satisfying all those intentions is your ticket to instantiating that initial intention at the bottom. So we say that D is a requisite of C, and C and D are here typed as procedures yielding properties of individuals. If for all worlds at all times and every individual, it is true that if you're an C thing, then you're a D thing. And why do we use the property true? That's again because we're dabbling with partially defined truth conditions here. So if you have a truth, if an antecedent is produced by an improper procedure, then you end up with a falsehood. Then every implication would be a falsehood. But of course, that will completely undermine any definition of requisites. So that's why, short version, but that's why we must predicate being true of the antecedent and also of the consequent here. That's by the by. What we could also do is that we refine a procedure. So we had the property of being prime. And that procedure, the trivialization of prime, goes together with a predicate, is a prime number, is a prime. Because very roughly, semantic and syntactic structure should more or less match each other. But that gets in the way of a lot of inferences. What can you infer from an atom? Nothing, right? So you have to refine that atom prime into a molecule that comes with a lot more information. So you can take, and it's always an atom, so a one-step procedure. So it's almost always a trivialization. You can't really do much with a variable. So a trivialization, and you can refine that into a composition or a closure. And that composition or closure will be much more informative. So I say that number 5 is a prime That's the literal meaning of 5 being a prime. But then you can ask me, well, what is prime? Can you refine that for me? Yes, I can. And then I give you this. I could, for instance, give you this closure, from which you could infer a number of things. Just as we, so think again, why I'm bringing this up. So go back to the example of the first slide. A divorced bachelor walks in the park. Can you infer that a man walks in the park? You spell out the some of the requisites of being divorced, being a bachelor. In this case, a bachelor. Well, you cannot be a bachelor unless you're a man. So this regarding the issues here with the falsehood, necessary falsehood of the premise, you could infer that yes, indeed, a man is walking in the park. If a bachelor is walking in the park, then a man is walking in the park. But that applies. All the business with requisites applies to intentions. If you want to do something comparable with procedures, we call that refinement. That's why I'm bringing this up. So if you want to infer something from 5 is a prime, that is not inherent to prime, just the trivialization of that property of being a prime number. If you want to unmask that property, then you refine that trivialization. And you can do, and that carries over immediately to refining properties that are mathematical or empirical that are impossible. That's the point of that. When it comes to intentions, we distinguish between predication de re and de dicto. And the counterpart of that in the mathematical case, if you go back to the largest prime, is the procedure occurring in the position of a functional argument occurring either with either hyperintentionally or extensionally. If extensionally, then we descend to its product. If hyperintentionally not, then we talk about the very procedure and predicate something about that procedure. So if I say, for instance, Vulcan is a planet, then if you're a fan of dual predication, as I am, you are dealing with an ambiguity. But it's not a lexical ambiguity, it's a structural ambiguity. It could mean that I've identified a particular individual, and then I'm predicating of that it is a planet. If I do that in this case, I would get a truth value gap, because as we found out, Vulcan doesn't exist. That office is unoccupied. Or I could turn to predication de dicto. I could say the office of Vulcan is vacant. That's one form of that predication de dicto can take. The other one is to turn to requisites. So I could be stating explicitly that the property of being a planet is a requisite of the office of Vulcan. So if you want to be Vulcan, the planet, one thing you must do is be a planet. Okay. And what, for instance, the Meinongians would invariably be at the level of predication de re, right? Because they only dabbling in objects. So for them, Vulcan is an object that doesn't exist, but it's an object. It's a non-existing planet. They simply do not have the notion of predication de re, de dicto, nor do they want it, of course, because in their super domain, they have Vulcan. So you can refer to Vulcan just as easily as you can refer to Mercury. semantics works along the same lines. Same thing with requisites. They wouldn't talk about requisites. They would talk about characterization principles. And again, why would they have predication predictor? Well, but it's critical to me to have that. Otherwise, I'm limiting my expressive power radically. And also, if I couldn't have predication, hyperintensional predication, then I could not accommodate Andrew's wish to come up with truth value T before. I would just be at the level of Dirac. So extensional predication, I would have a gap instead. Another thing that I should just bring that up is that in that domain, they have Vulkan, they have Sherlock Holmes, they have round squares, they have no demarcations because they don't have a typed universe. Whereas this is super, what I'm offering you is super typed, right? So that's why I need one kind of semantics for mathematical discourse, another kind of semantics for empirical discourse. Even the kind of discourse that is extreme, because we have dealing with intentions that are trivial, or at the very least never yield truth value true, or either falsehood or a gap, whether we talk about a proposition or a property or relation. We have a completely different theory of fictional discourse, for instance, of religious discourse, of mathematical discourse, of discourse about, and then scientific discourse, if you like. But on the other hand, the discourse we have for unicorn and for zebra is exactly the same, just an intention, and one of them happens to be instantiated and the other one doesn't. So this is, again, far removed from causal theory, right, where zebras are privileged over unicorns. But that empirical accident is not reflected in our semantics, but it is reflected in the semantics of Kripke. That's why I've been hopping on predication to dicto and the rest of it. Okay, so the last case here.
Bjørn, I sorry for interrupting, but if we're going to be able to have any questions, maybe it'd be good to find a place to break. I know we started late, but
okay. So I'll just simply tell you what is on the slide. So this is how we handle impossible belief, right? So Tillman is related to a procedure that is typed and structured to yield a truth condition, and Tillman hasn't realized yet that truth condition is impossible. Right? And this we can quantify in, so this is a way for us to reason about impossibilities here. Right? We have an impossible procedure, then we can describe lots of properties of it without reasoning from it. Right? We're not calculating anything. Okay, so let me just wrap it here.
Okay. Bjørn, and